Welcome to the session on forces and friction, inclined planes. The objectives for this session are to solve problems which involve smooth or rough inclined planes. When solving problems which involve inclined planes, it is generally easier to resolve parallel to and at right angles to the plane. Taking a look at this diagram, we have a particle m on a raised slope at an angle alpha. We have the reactionary force and the weight shown on the diagram. Let's now take a look at some notation related to this. R with a downward arrow, as shown, means resolving down the slope, and R with two vertical lines means resolving parallel to the slope. R in the upward direction means resolving up the slope. Similarly, if we have different arrows, so R with an arrow in the other direction means perpendicular to the slope, or resolving perpendicular to the slope, and R perpendicular means resolving perpendicular to the slope. Let's now take a look at an example. A box of mass 20 kilograms slides down a smooth slope which is angled at 30 degrees to the horizontal. We are required to draw a force diagram showing all the forces acting on the block. Then, to find the size of the normal reaction of the slope on the block, and finally to calculate the acceleration of the block. So let's solve this. We're going to take a look at part A first. So here's our slope inclined at 30 degrees and our 20 kilogram box. The reactionary force is as shown and the weight is 20 g. The missing angle of the triangle is 60 degrees. And this angle here is 30 degrees. So here's our box of mass 20 kg. The slope is angled at 30 degrees. The weight of the box is 20 g, or 20 times the force of gravity. Remember, this is linked to force equals mass times acceleration. Mass is 20, acceleration is g, so we have 20 g. And so we have our diagram. Now that we have our diagram, we can have a go at part B. In part B, we are required to find the size of the normal reaction of the slope on the block. So let's solve this. Remember, here's our box of mass 20 kg, angled at 30 degrees, and we're required to find the size of the normal reaction. This angle here, remember, is 30 degrees. Resolving perpendicular and parallel to the plane will facilitate our working. So, if we resolve in the perpendicular direction, we have R equals, and in the opposite direction, 20g cos 30 degrees. Substituting cos 30 equals root 3 over 2. And substituting g equals 9.8 gives us that R equals 170 newtons. And now for part C. We are required to calculate the acceleration of the block. So again, the box has mass 20 kg. It's angled at 30 degrees. And the acceleration is going downwards, so down the slope. Notice that in the direction parallel to the slope, we have a force acting or equal to 20g cos 60 degrees. So we can now resolve, and this time we're going to resolve in the parallel direction of the slope using F equals ma, or force equals mass times acceleration. Giving us 20g cos 60 degrees equals the mass, which is 20, times the acceleration, which we are required to find. And this implies that A equals g cos 60 degrees. And plugging in g equals 9.8 meters per second squared gives us that the acceleration is 4.9 meters per second squared, because of course cos 60 is a half. Now let's take a look at another example. A block of mass m kilograms is pulled up a rough slope by a force of 12 newtons that acts at an angle of 30 degrees to the slope. The block experiences a constant frictional force of magnitude 5 newtons. Given that tan alpha equals 2 over root 5 and that the acceleration of the block is 2 meters per second squared, find the value of m. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We're going to begin by drawing a diagram first. Here's our mass, m kilograms, on our slope. And here's the force of 12 newtons, which is pulling our mass at an angle of 30 degrees. We have a frictional force of magnitude 5n. We also have that tan alpha equals 2 over root 5, where alpha is the angle at which the slope is inclined. Our acceleration up the slope is 2 meters per second squared. And we are required to find the value of m. If we resolve parallel to the slope, in the upwards direction, we have a force 12 cos 30 degrees. And in the downwards direction, we have mg sine alpha. So we have 12 cos 30 degrees minus mg sine alpha minus 5, as shown, equals mass times acceleration, so m times 2. So force equals mass times acceleration. Now, since we have tan alpha equals 2 over root 5, we can use a right-angled triangle to help us find sine alpha. So first use Pythagoras to give us the value of the hypotenuse, as shown. And this value of the hypotenuse is, of course, 3. Now we can find sine alpha. This is going to be equal to opposite over hypotenuse, so 2 over 3. We can now plug this into our equation as shown. We know that cos 30 degrees equals root 3 over 2. And we can now solve for m. We can also plug in g equals 9.8 meters per second squared to give us m equals 0.632 kilograms. This brings us to the end of this session. If you have understood its contents, you should be able to solve problems which involve smooth or rough inclined planes. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.